Good evening, folks. Right, I'll say it first, just so you know what this is about, and if you want to follow what I say, it would be good, because this is as close as I have come to slam dunking something, but haven't slam dunked it, only because it's been in the last 24 hours that I've jumped into a little bit deeper water with this thing. The moon has nothing to do with the tides. I'm not slam dunking it, but what I will say, it doesn't really matter what anybody else says, okay? So that's where I'm stuck. I'm stuck in between. It doesn't really matter what anybody else says about this, right? And a slam dunk. But I'm not going to slam dunk it in case I've missed something somewhere. But I don't think I have. That's why it doesn't really matter what anybody else says. When I work stuff out, those of you who know me by now, everything that I work out with their numbers. Distances, sizes, that kind of a thing. Speed. I don't use anything, any number, any angle that nobody else has. Because with the information, the way I'm working these things out, it's with their numbers. Now, if you understand their numbers, right, I'm not understanding why you guys aren't understanding more about what I'm saying. I am not making anything up. I'm not making a number up. I'm not bringing in a hypothetical particle to play the game. Everything I use are facts, but they're facts. I don't think a lot of this is going to turn out to be factual. The moon has nothing to do with the tides on planet Earth. That water is being shifted or moved or something by something else. It is not the moon. And I am so close to SDing this thing, but I'm not going to. Now, a quick moon, earth, and distance brush up. This is another thing. If you don't know the size of the moon relative to Earth and the distance, I mean no. I don't mean I mean understand. No. The distance, right? And the sizes involved. We have planet Earth at 12,742 kilometers in diameter, and we have the moon, it's 3,474 kilometers in diameter. Planet Earth is 3.6 times bigger in diameter than the moon. So we have a diameter that is 3.6 times bigger than the moon, okay? The average distance between the moon and Earth is 384,000 kilometers. What we mean by average is it gets a little bit further away, like, I don't know, maybe close to 400,000, but it also gets as close as maybe, I don't know, 360,000. That is the average in its slightly elliptical, apparently, orbit, okay, around us. That distance, there are 30 planet Earths in between the moon and Earth. Like I say, there are 108 suns in between the sun and Earth. There are 30 planet Earth diameters in between the moon and Earth. Right here, right now, we have 1.5 meters. We have a 1.4 centimeter diameter moon and a 5 centimeter, oh, Daisy the cow. I actually forgot. Again, that's Daisy the cow. We have a 5 centimeter diameter Earth. Now, when I say 5 centimeter, I am not making anything up. I am five centimeters, right? This is to scale. Over here, 1.4 centimeters. those two sizes are smack on the money, right? They are proportionally correct. The distance in between this Earth and that moon are bang on the money. It's proportionally correct with the size of the planet. This is how it would look. Now, knowing this, there is something, when you look at it a bit closer, it just does not make sense. Right. This is the equator, right? As you know, the moon, it would be way, way, way that way, because it is the equator, we spin that way, and the moon kind of goes like that, doesn't it? Right? It's the equator line that is northern hemisphere, southern hemisphere, and the moon kind of hovers in between with its orbit, our little axis spin. A long way away, it is in line with the equator, and it goes up and down. Now, knowing this, do they or do they not say that there is a bulge? That planet Earth, the tide is always kind of bulged up because of where the moon is, and Earth, as we spin on our axis, we kind of move into the high tide. It's not the moon dragging the water around with it. It's us moving into a bulge on the planet. Now that is highly illogical. It makes no sense whatsoever. The reason it doesn't make any sense is because we are spinning that way. Now, to get a bulge here, you would need a bulge before it, and before it, and before it, and before it. There is too much land. There is too much land for planet Earth to be turning into any bulge of water on its surface because of the moon's gravitational pull on it. They also say that there is a bit of a bulge at the back or behind because there are two high tides, aren't there? 2 in a day and 2 low tides. Where would you think the biggest pull on our planet would be if the moon is basically hovering above the equator? That is the split between north and southern hemispheres. You'd think the pull would be coming. Now, the highest tides on this planet, this is the bit that I've learned today, and I'm telling you, the moon has nothing to do with the high tides. Right, we have on the right there, Nova Scotia, right? The Bay of Fundy. It is, we're looking at the bottom one. That is the Bay of Fundy in Nova Scotia. That right there is Ungava Bay in Quebec. Right? And we keep going left. So we're going to run across Canada, right? And we get to the Cook Inlet in Alaska. Right? See how high up north we are? Well, that Cook Inlet in Alaska is the 4th highest tide on this planet. Right? So in order of big to small, we have Bay of Fundy, Nova Scotia. Then just to the left of it, we have Ungava Bay in Quebec. The 3rd highest tide on this planet is, we're going to skip past Alaska right now, and we're going to go all the way to the UK, and we have the Bristol Channel. What's that? Gosh, must be a leaf or something. Something it didn't freak me out. I was ready to jump up onto that globe. Bristol, in the UK, the third highest tide on this planet, right? And then we go back to Alaska, and we have the Cook Inlet. That is the fourth. And the fifth highest tide, the place where it has the highest tide on this planet, is in Argentina, right? A place called Rio Gallegos, near the very most southern tip of Argentina. Now, if you look at that, anybody who knows a bit of geography, you'll see that all of the highest tides, the four highest tides on this planet, are all up north. Canada, Alaska, and the UK. But channels, right? Why on earth are the highest tides, apart from one, right? Four of them are all up at the north. Guys, it doesn't matter what anybody says, and I really don't know why I'm not slam dunking this. This is us looking down as if on a flat planet, right? You're looking down onto the Arctic, the North Pole. Now look, you have the UK, the Bristol Channel. So that is the North Pole. That is the centre at the top, we're told. UK, Nova Scotia, Quebec, that, what is it called? The Ungava Bay. And then up there, Alaska, the Cook Inlet. Now, if you look at it, there's a different way of looking at this. If you look at down, why are all the high tides at the top, the highest tides on the planet, at the top of the planet? If it is a planet, why? Can you see what I'm saying? Now, once again, this has nothing that anybody, this has nothing in it, right, that people shouldn't understand. It's illogical because the moon is, we see it, the equator is its center plane kind of a thing. Now, this is highly illogical, right? So planet Earth is spinning. We spin counterclockwise, right? So we're spinning this way. Right here, I have it on the angle of 23.5, I think it is, degrees, right? That they say the planet is tilted. So depending where you look at it from, when you're looking straight onto it, you'll see how different sides see the sun more than the other side, depending where Earth is on its orbit around the sun. Because when we're around the other side of the sun, it is this top part that will get most of the sun when the sun is that way. But 6 months later, when Earth is this side, it's here that gets most of the sun because of the tilt. That is one of the reasons they tell us that for the climate change of the seasons, okay? So that is kind of how, well, like that way, how there is the furthest from the sun and the closest to the sun. No, we have an elliptical orbit. That is what decides closest, furthest. But this tilt, depending on which side of the sun the planet is what determines what is winter in one hemisphere and what is summer in the other. And then 6 months later, it changes because of the tilt. 6 months, one is closer, well, obviously it goes round, it gets hotter, colder, colder. But it changes. Now, here's the thing. This again is looking at the highest tides on this planet. That's the Arctic, right? I'm holding it straight. So this is with the 23.5 degrees axis tilt. Okay, so we're going that way. And zoom out. Now here we go. Bristol in the UK. Nova Scotia and Quebec, right? And we keep going, and up there we have Alaska, the Cook Inlet. Now the thing is, if we get rid of this 23.5 degree and we set it flat, right? And then we look down on it, you can see all of the highest tide places, but that doesn't really look like that with the 23.5 degree axis tilt, if you know what I mean. There you go. Now this is looking straight down, right? So why are the highest tide points all at the north of the planet? Why aren't the highest tide points somewhere along the equator, where the bulk of the moon's pull should be? Now look at these tides. We're only looking at the blue box, the rest is the eclipse. The Bay of Fundy in Nova Scotia, 38.4 feet. That doesn't mean too much to me because I always do it in meters, but when 11.7 meters here in Bundy, I think at the very most we get a king tide of maybe 3 or 2.8 to 3. 11.7 meters. Ungava Bay, Quebec, 32 feet, 9.8 meters. And then Bristol comes in at number 3. Then the Cook Inlet, Alaska, at number 4. And totally random, as the 5th of the biggest tides on the planet, we have in South America. There. Right? Now, that's right next to Antarctica. Now, what does it prove? Well, I would say that anybody with any common sense, right, if they understood what I just said about where the highest tides are on this planet, anybody with, I do believe personally right now, anybody who understands the geography of the planet and understands where the equator is and the moon is in relation to the equator, and where those 4 high tide spots are, anybody with any common sense and who properly understands the dynamics of it all should be saying right now, that makes no sense. The highest pulls should be here, where the equator is, not up there. And we're talking some big tides. The other thing, and this is kind of like the cherry on top of this, right? There is no tidal anything in any of the lakes. Now look how many lakes are at the closest to the highest tides on this planet, right? Look, there is no tidal effects from the moon on those bodies of water. Once again, it doesn't matter what the science says. If you are going to try and make me believe that the moon is pulling all of that water and creating these tides of 11 meters, 12 meters, nearly 40 feet on this planet, that it's not going to budge. One of these lakes, some of these lakes are hundreds, not thousands of kilometers long, aren't they? And hundreds wide, 1,000-2,000 deep. They're not like puddles, but there is no tidal action whatsoever. What they say is there is, but it's so small that you can't notice the difference. There we are again. An invisible, massless tide. So small, you can't detect it. But if the moon is dragging all of this water, why is there no movement in one single lake, enclosed body of water on this planet? I grew up in the Mediterranean. We have the Straits of Gibraltar. That right there, it's the only connection to the ocean. And the Straits of Gibraltar are rough, but they're nowhere near as rough as what's up at the North Sea, North Pacific, North Atlantic, the crabbing boats, all of that stuff up there. It's mental when it comes to the water. The moon does nothing to the tides. I'm not going to slam dunk it because I'm not that reckless. But definitely, anyone with any common sense seeing these numbers should understand that if the moon were going to be pulling at the water, the highest tides would obviously be where it's closest to us, and that is the equator, right? Now, one more thing before we wrap this up. When I say that that is the proportionally correct distance for Earth, the moon, and the distance in between, and that 1.5 meters. So at 5 centimeters times 30, it's 1.5 meters. That is the correct distance, keeping it proportionally correct with a 1.4 centimeter moon and a 5 centimeter planet Earth. Now, just to bring it up that little bit bigger, right, during the day, what I have out there, let me just unplug your umbilical cord. Right, what we have to scale, right? Right, let's see if I can zoom back up a bit. Right, there we go. Right, now, let me come back a bit more. It would have been cool to do this during the day, but you know how it is, life catches up and it doesn't work out like that. Right, there is a planet Earth, has a diameter of 30 centimeters, right? 30 centimeters. From there to this chair, it's 9 meters. So that's 30 times the 30 centimeters is a 9 meter gap, and we have an 8.3 centimeter diameter moon. This is perfectly to scale with the distance to that 30 centimeter planet Earth, right? Everything is proportionally bang on the money. Now, I know a lot of you don't like this because I used to do this with the sun, trying to explain why it is so ridiculous to think it takes 8 minutes and 20 seconds for it to get its light here. This is proportionally correct with that planet Earth. I'm going to walk over there. This isn't about the shadow and the eclipse. This is about the overall size of the two things that we're talking about. There is no way that something that big would be pulling at the water on that planet and doing everything that it does to the water at the same time as not affecting any of the big lakes. It's highly illogical. It's also highly illogical that if the moon is always closest to us at the equator, that the highest planet tides, or the highest tide on this planet, are all up, well up into the northern hemisphere. Now, it doesn't matter too much what anybody says about this. It doesn't matter if you've been teaching this and you think you know all of the angles. It's illogical. It defies logic and it defies common sense. It's a lie. The moon can have nothing to do with the tides on this planet. It doesn't add up. It does not add up. I'm going to have a dig and find out what times those tides are, because it doesn't make any sense. The high tide is always on the top of the planet. The highest tides are on the top of the planet. Doesn't make any sense, none whatsoever. But there will be people out there trying to find the logic in it. Maybe have something invested in the moon having something to do with the tides. But it doesn't. These are their numbers. This is the map of whatever it is, whether it's flat or round, that we use, they give us. And 4 of the highest tides are all in the northern hemisphere. But not just the northern hemisphere. This is the equator, where the moon is supposed to be pulling the most. But the highest tides on the planet are all up here. That makes no sense whatsoever. And then, when you look at the flat Earth, now this is not a map with a flat Earth on it, it just has a view down onto the North Pole. That's Russia, that's Alaska, that's Canada, that's the US, that's Europe. Now look from here. You're looking, that is the center of the planet, right? Don't they say flat Earth, this, that, and the other, and the stuff is revolving around somehow like this? Listen, guys, the high tides, the highest tides on this planet are all up at the north, as if something is pulling the water, or the water is coming out of somewhere, but up here. It's not logical. It should be happening down on the equator. This is kind of a fact. This is where common sense, personal common sense, and the ability to be able to think for oneself, and in the hope that believing your own judgment, trusting your own judgment, the moon has nothing to do with the planet's tides. Slam dunk. The moon has nothing to do with the tides. All right, latest peeps.